In this video, we are going to learn what is probability. Probability is the way we quantify uncertainty. So how do we add elements of randomness to statistics? For example, we can randomly assign subjects to treatments, or we can randomly select people for a sample. How does probability work? First, the possible outcomes are known. Second, however, it is uncertain which outcome will occur for any given observation. Randomness in a common games makes them fair. For example, each player has the same chance for each possible outcomes. It's a fair game. There are more examples. When we flip in a coin, when we roll a six-sided die, or when we shuffling cards, they are all fair games. Note that we know the outcomes of flipping a coin are heads or tails. However, we don't know for each flip of a coin if we will get a head or tail. The number of observations taken can affect the outcomes. A small number of observations may provide different results than expected. A large number of observations cause the summary statistics to settle down and get increasingly closer to a particular number. The law of large numbers states that as the number of trials increases, the proportion of the occurrence of any given outcome approaches a particular number in the long run. The long-run proportion provides the basis for the definition of a probability. Random phenomenon is everyday situation for which the outcome is uncertain. In the short run, the proportion of times something happens is highly random and variable. But in the long run, the proportion of times something happens is very predictable. The probability of a particular outcome is the proportion of times that the outcome would occur in a long run of observations. Rules of probability, or we can say axioms of probability. Axiom means it is the statement is regarded as self-evidently true. First, since these are proportions, all the values must fall between 0 and 1. Note that you could show probability as percentages. For example, you can show probability of 0.5 as 50%. The trick is use 0.5 times 100, you will get 50. Then you just add the percentage symbol. Second, the total of the probabilities for all possible outcomes is equal to 1. We have already seen this when we created a frequency for the football dataset. We can use this dataset to check two rules of probability. Rule 1. All the proportions, or we say relative frequencies, were between 0 and 1. These columns, all numbers in these columns are between 0 and 1. Rule number 2. The sum of all the proportion was 1. You can verify rule 2 by doing this calculation. Here are a few definitions to get us started. First, what is sample space? Sample space is the set of all possible outcomes. Generally, the first step in finding probabilities is to define the sample space. Second definition is event. Event is a subset of the sample space, a particular outcome or group of outcomes. Here is a formula to calculate the probability of a particular event. The probability that the event A happens equals the number of outcomes in the event divided by the number of outcomes in sample space. Here are some examples. When we flip a coin, we either have a head up or tail up. So that's why the sample space has two components, head or tail. We define the event as flipping a head using the formula here. The number of outcomes in the event is 1 because we only accept head up. And the number of outcomes in sample space is 2 because it is either head up or tail up. That's how we calculate the probability of a heads up. Second example is roll a 6-sided die. When we roll a 6-sided die, we can either have 1, 2, 3, 4, 5, 6 as outcomes. So that's why the sample space, we have 6 elements in it. 1 to 6. Second, we define the event as rolling an even number. Even numbers are 2, 4, 6. And the number of outcomes in the event is 3. Number of outcomes in sample space is 6. So that's why the probability of rolling an even number is 3 divided by 6. I will explain law of large numbers in this example. First, we know that the probability of getting a heads when you flip a coin should be 0.5. This is called the theoretical probability because it is determined by knowledge of a process. Let's say you flip a coin 5 times and you get 3 heads. So the probability that you have a heads up is 3 divided by 5. This is called empirical probability because you do something and count the number of outcomes for a particular event. Now you flip the coin 10 additional times and you get 4 heads. So running total is 15 flips with 7 heads. Now the empirical probability of a heads up is 7 divided by 15. And you continue this experiment. Now you flip the coin 100 additional times and you get 51 heads. So running total is 115 flips with 58 heads. So the empirical probability that heads is 50 divided by 115. Notice that the more trials we do, the closer the empirical probability gets to the theoretical probability. This is the law of large numbers.